students, welcome back to my class. In the series of learning data structures through C, in the previous video, we discussed about the memory representation of queues. Well, in today's video, we will discuss the types of queues, the different varieties of queues. So those who are new to my channel, please subscribe to my channel and click on the bell icon so that you can get the notification of all the new videos. Watch the video till the end, do not skip the video. And if you like the video, please click on the like button and share the video to all your friends. Types of queues. So you have different types of queues. You have simple queue, you have circular queue, you have double-ended queue, priority queue like this. So let us understand these types of queues one by one. The first one is simple queue. The queue that what we have already discussed is that is what the simple queue. So it says the addition of new item so-called enqueue operation and the deletion of the existing item so-called the dequeue operation takes place at two different ends. We all know that. So from the rear end we do the enqueue operation and from the front end. So this is what the rear end. So from the rear end we perform the enqueue operation and we perform the dequeue operation, that is deletion, from the front end. So from the front end we perform dequeue operation, from the rear end we perform the enqueue operation. Enqueue means inserting the elements, dequeue means removing the elements. So it is performed at two different ends, rear end and front end. From the rear end we do the enqueue, from the front end we do the dequeue. So it is the ordering principle so-called first in, first out. So this is what the simple queue. Circular queue, the second type of queue. The name itself tells you it is going to form a circular representation. So here in this, we represent this usually in linked list. So we use the circular queue especially in the linked list representation. And it can also be represented with arrays also, that is with static representation also. So it can be implemented in both the ways, both using arrays as well as using linked list. Any doubts regarding memory representation, please refer to the previous video where you can understand the static representation using arrays and dynamic representation using linked list. So what happens in circular linked list? As the name itself tells you, it is going to form a circular representation. The last node is connected back to the first node to make a circle formation. Look at here, the node representation. As you all know, the node contains two parts. One is data part and the other one is link part. So it is going to link to the next node. So here just observe, this is the first node having the data 10 and the address of this node is 100. So this address that what we have here, which is represented by the front pointer. So we will have the front pointer which will have this address, that is 100. So it will point to the next node where the link part will have the address of the next node, so 200. So it is pointing to this. So it goes on like this, 300, then it is 400. Now this is what the last node I can say. The last node is connected to the first node. So now the rear pointer is pointing to 100. So I can just say both front and rear will be having the address 100, means it will be pointing to this first node. So here this rear is back to this front node. So this type of formation we do especially when we want to use the memory effectively. Just imagine we have dequeued the elements. So how we dequeue, how we enqueue? The elements are added at rear and deleted from front. So we add as usual in the queue method, that what we do, we add at the rear end and we delete from the front end, of course. But the difference is both front and rear pointing to the first element itself, the first node itself. Look at here. The front node pointing to the first node and the rear pointer will be back to the first node, means rear also points to the 100. So here what happens, when I just remove this element, the memory will be available. I'll remove this also. Again the memory is available. Then in the static representation, when it says the rear pointer is pointing to the last element, the queue is full. But in dynamic representation, I can allocate the memory, right? Dynamically. Here, when the rear is pointing back to the first node, I can utilize this memory. So rear is pointing back to the first node means I can utilize this memory. And here when I go to the next memory, that is 200, again if the data is not there, memory will be available, so I can use this memory also. So I can just refer to the first node and once again I can fill the elements. I can use the memory effectively. So it is called as ring buffer. So I can use these buffers in a ring format where the rear end is pointing back to the front end means I can use these buffers again, memory buffers again and again. So this is the circular queue. Priority queue, the next type of queue. The name itself tells you it is a special queue where the elements are inserted based on its priority. So these types of queues are especially used by the processor because the processor sometimes has to process based on its priority. So some process is given the highest priority and some process will be given the least priority. So based on its priority, the items will be put into the queue and the processor takes those process and executes based on its priority. So it says here the element is assigned with a value called the priority of the element. That is, each data that what we have inside the queue will have its own priority. And elements are inserted from any position based on priority. Means, based on the priority values, we do the insertion and deletion. It's not that you only have to do from the rear end or you have to do from the front end like that. The rear end, front end, at any positions I can do the insertion and deletion, but it's all based on its priority. Right. So for example, the element A is with priority 1, C with priority 3. It goes on, I can have n number of elements with n number of priorities. So these types of queues are specially used with processor. So when we understand the processor execution, that is how the processor executes the process. Process means task. So when you switch on a system, you give n number of tasks. You switch on the system, when the desktop screen appears, you press number of keys from the keyboard. You may just press refresh button 10 times. You may try to open some application 5 times. So all these are process tasks that what the processor has to handle with the help of operating system. So operating system is going to manage the task. It is going to handle these processes. It is going to decide how the processor has to process means the queues comes into picture. It will decide which will be the first task to be processed. So at the background level, the queues will be working. The queue data structure will be working. Hope you have understood with this. The last type of queue, that is DQ, or what we can call it as double-ended queue, means the elements can be added to and removed at both the ends. So it's not that you only have to insert the items from the rear end. You can also insert from the front end also. It's not that you have to remove the elements always from the front end. You can also remove it from the rear end also. It says you can do the insertion and deletion of the elements from both the ends. NQ means inserting. You can insert from the rear end as well as front end. DQ means deletion. You can delete from the front end as well as from the rear end. So this is a special type of queue and the most complex type of queue where it provides flexibility to do the insertion and deletion from both ends. But it's quite difficult to manage this. The coding part of DQ, that is double-ended queue, is quite complicated because we need to manage both the pointers to perform both the operations at different ends. So this is what with the types of queues. That's all for today's video. See you in the next video. Till then, take care. Bye-bye.